part 2. Here's what I did. For the year, we were getting weird numbers, right? Weird results. So here's what I did. I made 1971, that was the first year, so I made it equal 1, and then all the data in the Y column, basically I just chopped off the last 3 numbers. So, this 323 really means 323,000. When you chop off numbers, by the way, that's not called rounding, that's called truncating. Anyways, so theoretically it should work. It should produce valid results, but smaller numbers. That was my hope. So here we go. Let me get my ugly mug out the way. If you notice, with the original data, we got 0.922 as our R squared, and it stayed 0.922. What's that tell you? That what I did mathematically is valid. So we still have the same R value, and same thing with exponential. It said 9 or 0.922 the first time, and it says 0.922 this time as well. So linear exponential are tied still. Quadratic, it said 0.926 the first time. This time it says 0.925. So that one was a little tiny bit off. And it might have something to do with the truncating. Power, last time it said 0.933. This time it says 0.841. What's that tell me? That maybe instead of truncating, I should have rounded properly instead of truncating. And this one's way off. Initially we got 0.922. This time we got 0.758. But here's the main thing, though. Look at our equations. There's no E nonsense going on. So we used smaller numbers. We could have taken all of the original data and just divided it by 1,000, or divided it by 100,000, 10,000, and then we would just have to remember to multiply by that same amount later to get answers that make sense. But look at this one. Look how pretty that is. Now, there's no wacky numbers. Even the quadratic one, pretty. So now, quadratic, I think that's the highest one. Exponential and linear were both tied at 0.96. Okay, so doesn't matter which one we use. I'm going to use the exponential one as my equation. Now, crossing my fingers that for the year 2019, I already know what the answer is because I looked it up on Google. The number of violent crimes. Yep, I got it right there. Yep, 1.2 million. Let's see how good this prediction model is. There's a lot of data, so it should be a pretty good predictor, except something happened in the late 90s called the crime bill that made this model inaccurate. So, okay. So, that being said, yeah, I'm definitely going with exponential, because I know historically what happened in the late 90s. Let's see, so 323, I'm going to use 324, and I'm going to use 1.05. 324 and 1.05. 324, 324 times 1.05 to the power of 38. Remember, 38, that's 38 years after 1971. Cross my fingers, cross my fingers. Okay. Alright, so, remember, what we did was, I need to add 3 zeros to that. So, let me chop this off. Minus point. I'm just chopping off the decimal part real quick. Okay, and then I'm going to times that by 1,000. so it's off by quite a bit. That's 2 million, right? In reality, in 2019, there were only 1.2 million violent crimes, not 2.1 million violent crimes. So that model, the exponential model, was quite a bit off. But keep in mind, I rounded this one up slightly, so I don't know how much of an effect that would have. Yeah, not much of an effect, actually. And I rounded this number slightly, so exponential. But there you go. At least we got an answer that vaguely makes sense. 2 million violent crimes as opposed to the nonsense we got before. So, and interesting that it did not rise at a logarithmic would be the best one. Okay, I'm gonna try. Why? It's 436. I should be grading my test from first and second period, but this is way more fun. Let's see what logarithmic does. Okay, so let me go get the logarithmic equation. Oh, even the power one might be valid. I'm gonna try power first, because you guys see how the power one is starting to curve, or has a big sharp curve right here, but then it levels off. So maybe that one would be a good predictor. Basically what I'm trying to do is see if I can get close to the actual 1.2 million figure. Hey, I'm gonna let you guys in on a little secret. The number of COVID deaths that they are predicting, they're using several models and they're blending the models to get one number, by the way. How do you do that? I have no clue how you blend two models. That is above my pay grade. But I understand the concept in general. Okay, let me come here. I wrote down the formula or equation, whatever you want to call it. Mother dookie. What just happened? What in the world? What in the world? What did I do? Welcome to my world. Okay. So we have 273 times x, which is 38, to the power of 0.284. Bam! And then, oh, that one's not too bad. So if I multiply that by 1,000 equals 767,000. Remember, the real number is 1.2 million, so that's 500,000 off. So maybe if I knew how to take the blend of if I knew how to blend a power model with a quadratic model, we'd get almost a perfect result. Yeah. Maybe if we just take the average of certain models. Maybe that's what they do. When they say they blend models, maybe they're just taking the average of different models. Maybe. I have no idea. No idea. Anyways, I told you I'd get to the bottom of it. Shoot. Math is not going to get the better of me. Not today, devil.